let you guys know. All right. Today is a huge day in the life of Calculus 1 here. So if I click over here to modules and scroll down, we are finishing up. I got one more problem to do in section 2.6, but then we're going on into 2.7. So if you notice your pre-section quiz, if you haven't done it yet, it is due by when? 11:30 tonight, so make sure you get it done, but hopefully you've already got a clue. This clue, what we're doing today, is word problems, related rate word problems. And you throw word problems into a bunch of science majors and things tend to fall apart. So I'm going to go through this thing and kind of give you guys the steps of actually how to handle one of these type of related rate problems. When it comes to the scheme of math in Calculus 1, we're going to be focusing on two different style word problems that we like to focus on. The first one you'll see today is related rates. The other one that you're going to see on the final exam is in chapter 4, which is called optimization style problems. And how they're worded is completely different, and I will show you when I get to the other section, chapter 4, how they relate and how you can tell the difference between the two problems. And I'll focus a little bit on that today. But today's, like I said, a real important day because we're going to be doing word problems, and that seems to be, number one, it's important. Number two, and because it's so important and the math department emphasizes this, they tend to put a lot of point totals on the final exam on this type of material. So it kind of all relates. You've got to master this stuff. So let's go ahead and get started on it. So, but before I did that, there was one problem in section 2.6 I wanted to do. So here it is. This one says use implicit differentiation to find the equation of the tangent line to the curve 4x squared minus 4xy minus y cubed equals 84 at the point 1, negative 4. All right. First things first. Anytime you hear the word find the equation of the tangent line, what are you going to use? I've been trying to program you on this one. Point slope. So you got to have the point slope formula for a line, which is y minus y1 equals m times x minus x1. Okay? That's my goal. And guess what this is right here? We're supposed to find the equation of the tangent line of this interesting equation here. This is my equation. 4x squared minus 4xy minus y cubed equals 84 at the point 1, negative 4. So this is my point. This is your x1. This is your y1 that we're going to be plugging in. Okay? So I've got the point, and this is nice in the sense that when we always did them before, they just gave you x equals 2. You had to plug it into the equation to figure out y. But with these implicit style equations, they're going to give you the actual point. 1, in this case, negative 4. Now, next thing I need to have is the equation of the tangent line. So I'm going to take my equation, the slope of the tangent line. 4x squared minus 4xy minus y cubed equals 84. And I'm going to take the derivative with respect to x, which means every time I take a derivative of x variable, it's a normal derivative. But every time I take a derivative of y variable, I got to tack on that times dy over dx. Now with this equation, stole this one off WebWork, there's something special on this one. So let's focus on the arithmetic here. First off, let's jump in with both feet and start taking derivatives. What's the derivative of 4x squared? 8x. Minus, what is 4xy, and how would you take derivative of 4x times y? Product rule. But with that minus out front, the trick is don't worry about the sign. Keep it out front and use a parentheses because we are going to distribute that negative later. Your function is 4x times y. Product rule. Derivative of the first times the second plus the first times derivative of the second. What's derivative of the first? What's derivative of 4x? 4, derivative of the first times the second, y, plus the first, 4x, times derivative of the second. What's derivative of y? 1 dy over dx. Close the parentheses. I'll distribute later. That's classic product rule. Derivative of the first times the second plus the first times derivative of the second, and you don't have to worry about your negative being out in front. You can distribute later and get the right answer. Minus, what's derivative of y cubed? 3y squared, what? dy over dx equals, and this is important, what's derivative of 84? 0, because it's a constant. So far, so good? All right, so now I'm going to distribute the negative. So 8x minus 4y minus 4x dy over dx minus 3y squared dy over dx equals 0. I want to solve for dy dx, which algebraically means I'm going to pull all the terms that do not have a dy dx on one side and keep the ones with the dy dx on the other. So I've already got the dy dx right here. I'm going to subtract 8x. I'm going to add 4y to both sides. This leaves me with negative 4x dy over dx minus 3y squared dy over dx is equal to 4y minus 8x. Now, I want to solve for dy dx. Once again, what a surprise, I got multiple terms with dy dx in it. So I want to factor out the dy dx. I'm left with negative 4x minus 3y squared equals 4y minus 8x. And then, what's my last move? Divide. Divide both sides by negative 4x minus 3y squared divided by negative 4x minus 3y squared. And this leaves me with dy over dx is equal to 4y minus 8x divided by negative 4x minus 3y squared. Now, who is this guy we just discovered? He is the derivative. He is not the slope of the tangent line. He is a function, and it's an implicit function in terms of x's and y's. So for me to actually get the slope of the tangent line, I've got to take my derivative, the dy over dx, and evaluate it at the point 1, negative 4. Which means I'm going to take this equation right here, and I'm going to plug in for x, 1, and y, negative 4. So this will be 4 times negative 4 minus 8 times 1 divided by negative 4 times x is 1 minus 3 times negative 4 squared. Now, the only thing I can do on this one is, try not to screw it up. Let's see here. 4 times negative 4, I can do that kind of math. Negative 16. 8 times 1 is 8. That'll be minus 8 divided by negative 4 times 1 is negative 4, but here comes the math. What is negative 4 quantity squared? 16. And what is 16 times 3? 48. Minus 48. So my slope of my tangent line is going to be negative 16 minus 8. How much is that? Minus 24. Very good. Divided by negative 4 minus 48. Negative 52. And negative 24 divided by negative 52 does reduce. They're both even there. And it's going to reduce to 6/13. That's what I got. And I did kind of put that on my calculator just to make sure. But yeah, I believe, was it 4 divides into both of them. So there you go. Negative 4 divides into both of them. Does that make sense? So now let's finish up the problem. Because I needed this guy because that is my slope. So I'll come back up here, and we just discovered the slope of the tangent line is equal to 6/13. Now plug it in. It'll be y minus the y coordinate, which is negative 4, equals my slope of my tangent line, 6/13, times x minus the x coordinate, which is 1. Now I'll admit to you that the most important equation of a line is the point slope form, because it's always the one that finds the equation of the line, but it's not the prettiest thing in the world. To make it pretty and to make it web work likable, we want to basically put it in slope-intercept form, y equals mx plus b. So I'm going to distribute the 6/13 and distribute the negative. That'll be y plus 4 is equal to 6/13 x minus 6/13. Then I'm going to subtract 4 from both sides, and that gives me y equals 6/13 x minus, and I'm going to take that negative 6/13 and subtract 4 from it and convert it to a fraction just to make it look good. Negative 58/13 is what I got. Minus 58/13. at classic web work. Don't expect really nice answers with these things, crappy fractions, but you can handle them. Does that make sense? Did I lose you guys anywhere with this? The hardest part was taking the derivative of this guy. And watch that one, and especially with the negative 4xy. Hold that negative over, and then the 4x times y, you can use the product rule standard on it, and then distribute the negative. That'll make sure that you don't mess anything up. Questions? All right. Well, this is what today's big lecture is about, and that is section 2.7, which is related rates. Now, we've been interested in, trying to figure out the rate of change. Anytime you hear the word rate, it means derivative. Find the derivative. Okay, rate means derivative. So, what we're going to be doing here is we're going to be having a particular equation, but it may be implicit. That means I have all my variables kind of jumbled up together, and I can't solve for one variable in terms of the other. But when it comes to a related rate word problem, when you think of rate, we think of things like miles per hour, feet per second. It could be, centimeters squared per minute. It could be meters cubed per second. Could be miles squared per hour. It's just some kind of a unit on top, but per divided by derivative of with respect to time, minutes, seconds, hours, whatever the case may be. So what we're going to be doing with these equations is we're going to be taking the derivative of whatever equation with respect to time. Makes it a classic physics style word problem. So, for example, I kind of discussed this one up here, but let's look at the example over here and I'll just kind of walk you through it. I gave you the equation x squared, r squared equals x squared plus y squared. In case you didn't know, this is the equation of a circle. X squared plus y squared equals r squared. But r is just defined to be the radius, and x and y are the x and y coordinates. Does that make sense? I would like you to, in this problem, I asked you to find what is dr over dt. So in other words, I want to know what the rate of change of the radius is with respect to time. So I'm trying to give it to in English because that's the way these word problems are going to work. Calculate the rate of change of time with respect, the rate of change of the radius with respect to time. So what I'm going to do here is I'm going to take the derivative with respect to time of my entire equation. Okay? And remember, every time you take a derivative of a variable, you've got to tack on a d variable over dt. That's just like we did with the other implicit differentiation, but now we're doing respect to time. There's no t variables in this thing, no? So every time I take a derivative variable, I got to tack on d variable over dt. For example, what is the derivative of r squared with respect to time? We take derivative normally. What's the derivative of r squared? 2r, but then you got to tack on times. It comes from the chain rule. Derivative the inside, dr over dt equals, what's the derivative of x squared? 2x dx over dt. Every time you take a derivative variable, you got to put that d variable over dt on it. And what's the derivative of y squared? 2y dy over dt. And each one of these things, dr over dt stands for the rate of change of the radius with respect to time. dx over dt stands for the rate of change of the x coordinate with respect to time. And dy over dt stands for the rate of change of the y coordinate with respect to time. Now, which one do you want to solve for? Well, in this problem, they said solve for dr over dt. Well, no problem. There's dr over dt. Getting by himself. To get him by himself, I divide both sides by 2r, and I get my equation. dr over dt is equal to 2x dx over dt plus 2y dy over dt divided by 2r, and this basically matches up with this guy here. But on occasion, they'll make you solve for one of the other rates of change. Down here, I said, oh, wait a minute, we would like to find what dx over dt is. Fine, there's dx over dt. You move this to the other side, divide by 2x, and you get the answer here. So you can just manipulate the equation and solve for whatever derivative that you want to solve for. But this is physics. So the trick to this stuff is going to be pay attention to units. All right. But as we get started on this, we're going to have to remind ourselves of some basic formulas. Because here comes the hard part about these word problems. They're going to describe a particular scenario to you, and within that scenario, you're going to draw a picture. And it's probably going to be one of these kind of pictures over here. And then from the picture and the relationship that you got of the variables that you actually personally have to come up with, you need to come up with an equation. These are the equations you should know. The perimeter of a square is 4 times s. The area of a square is side squared. The perimeter of a rectangle is 2 height plus 2 lengths. Obviously, the area is height times length. The area of a trapezoid is 1/2 height times base 1 plus base 2. Area of a parallelogram is going to be base times height. The circumference of a circle is 2 pi r. The area of a circle is pi r squared. Area of a triangle is 1/2 base times height. And if you happen to have a right triangle, you also know the relationships of the sides. A squared plus b squared equals c squared. The sum of squares of the sides of a right triangle is equal to the square root of the hypotenuse. So, in three-dimensional shapes, you need to know the surface area of a sphere is 4/3 pi r squared. The volume of a sphere, 4 pi r squared is the surface area. Volume of a sphere is 4/3 pi r cubed. Surface area of a cylinder is 2 pi r times h plus 2 pi r squared. The volume of a cylinder is pi times r squared h. Volume of a right cone is 1/3 pi r squared h. Volume of a cube is side cubed. Surface area is 6 side squared. And the volume of a parallel pipe, also known as a three-dimensional box, is base times height times width. And the surface area is 2 times the height times the base plus 2 times the base times the width plus 2 times the height times the width. Okay? Classic forms that requirements of knowing SAT and all that good stuff. So, but just a good reminder. So, turn page. If you watch the awesome pre-section video somebody made for you guys, you will notice that I actually did all these particular problems, and I wanted you to see the difference between the DVDR versus DVDT, the DADH versus DADT, so forth and so on. Okay, so I'm going to pick it up with this problem right here, problem number 5. If z squared equals x squared plus y squared, and dx dt is 9, dy dt is 5, find the positive value of dz dt when x equals 2 and y equals 5. All right, let me explain this problem here. First off, I've taken a traditional word problem and I cut out the words on it and I just put down all the information you need. I gave you the equation, z squared equals x squared plus y squared. I gave you dx dt, the rate of change of x with respect to time is 9 units per second, whatever. Dy dt is 5 units per second. Your mission is to find dz dt when x equals 2 and y equals 5. So the first thing you want to do is once you've got your equation, which is the z squared equals x squared plus y squared, you want to take the derivative with respect to time, just like we did a few seconds ago. So what's the derivative of z squared with respect to time would be 2z dz dt equals, what's the derivative of x squared? 2x times dx dt plus derivative of y squared is going to be 2y, but every time you take a derivative variable, you got to tack on that d variable, dy over dt. So now you've got your equation. Now plug in what you know and solve for what you don't know. Remember, the goal is to solve for dz dt. This is the variable. So all these other guys, the 2 is a constant, the z I'm going to plug in here. The z dt is what I want to solve for, so I leave him as the variable. It'll be equal to 2 times x times dx dt plus 2 times y times dy dt. Basically, I'm going to plug in what I know here. So let's plug in what we know. We know that dx dt is 9. So I'm going to take that dx dt and plug in a 9. I know that dy dt is 5. I'm going to plug in a 5 there. I'm trying to find dz dt when x is 2, so I get to replace x with 2, and I get to replace y with 5. And now just go solve for dz dt, but you got a problem. It's going to be a standard problem you're going to run across. They gave you almost enough information to solve for dz/dt. There's one letter they didn't tell you. Guess who they didn't tell you? Z. So if they don't tell you Z, you're going to have to go find Z on your own. So remember the original equation, z squared equals x squared plus y squared. Okay? So z squared is equal to x, which is 2 squared, plus y, which is 5 squared. I can do that kind of math. Z squared equals 2 squared is 4, 5 squared is what? 25. So z squared is equal to 29. So you got to solve for z. How do you solve for z? What kills off that square? Square root. But you got two options, plus or minus. Which one do they want? Well, because they said the positive value, you want to take the positive square root. So that would be the positive square root of 29. So now I get to plug in here, positive square root of 29. And then I can go solve. This will be 2 square roots of 29 dz over dt is equal to, let's see here, 2 times 2 is 4 times 9 is 36, plus 5 times 5 is 25 times 2 is 50. So I end up getting 2 square roots of 29 dz dt is equal to 86. I'll divide both sides by 2 square roots of 29. And this gives me dz dt is equal to 86 divided by 2 square roots of 29. 2 goes into 86. I can reduce that, was at 43 times. So I get the answer, dz over dt is equal to 43 divided by the square root of 29. Goodbye. There you go. And also, like I mentioned before, this is going to be a physics problem, so units are required. What kind of units would a dz dt have? Z represents some kind of weird distance, so units, meters, feet, whatever it happens to be. And time's going to be, t is going to be measured in time, seconds, minutes, hours, so you're going to have some kind of units per minute or units per hour or something like that. Pay attention to that. All right? So let's do our first word problem here. Suppose oil spills from a ruptured tanker and spreads in a circular pattern. The radius of the oil spill increases at a constant rate of 1.5 meters per second. How fast is the area of the spill increasing when the radius is 19 meters? That's all you got. So, first off, when you hear the word rate, I'm trying to tell you that means it's a derivative. So the first thing you want to do on any problems, you want steps? I'll give you steps. Step 1, read problem. Step 2, read problem again, draw a picture and label it. And you got to come up with your own variables. So, suppose an oil spills from a ruptured tanker and spreads in a circular pattern. All right, so I've got a nice little oil tanker right here. Here's the ocean. Here's my oil tanker going down. Okay, it's got a big crack in it, and the oil is spreading in a circular fashion. Okay? And from the center, this would be the radius. I will call it R, because that just makes sense. Okay? If the radius of the oil increases at a constant rate of 1.5 meters per second, pay attention to units. You hear the word per, you know it's a derivative. Who is this the derivative of? It is the derivative of what? The radius increases. The word increase, decrease, that's also another word, buzzword that's a derivative. The radius increases, so this would be dr over dt. Increasing also telling me it's positive. And you know it's a per meters per second, that would be the dr over dt. Pay attention to units. We like the Leibniz notation. Does that make sense so far? Keep going. How fast is the area increasing? Fast means it's a rate, area increasing. What are we looking for? dA over dt is the question, the rate of change of area, when the radius is 19 meters. How fast is the area increasing? Okay? Area increasing. That's the derivative of area. Does that make sense? Again, your guys getting into word problem mode. But the problem with this stuff is, and this is what kills students, is They didn't give you an equation to take derivative of. You got to come up with your own. This is why you draw pictures. What do you see on this thing? What is that? Circle. And they're interested in rates of change of area. They're interested in area. You happen to know the area of a circle formula? That's right. You're required to know that area equals pi r squared. You had to come up with that equation. Okay? Now, what are we going to do to calculate this thing over here? We're going to take this equation and take the derivative with respect to time. This will give me dA over dt is equal to, pi is a constant, leave them alone. What is the derivative of r squared with respect to time? What's the derivative of r squared? 2r what? dr over dt. So I'm just going to clean that up. That'll be dA over dt. Derivative of a is 1, dA over dt equals 2 pi r dr over dt. What do we want to find? We want to find dA over dt. So this is the guy I'm looking for. When the radius r is 19 meters, so I'm going to plug that in. So dA over dt is equal to 2 pi r is 19 meters. And dr over dt is how much? They gave that to me as well. What was that? 1.5. So it'll be, I'm going to leave the answer in terms of pi. 2 times 19 times 1.5 would be dA over dt is equal to 57 pi. But it's a physics problem. So you got to tell me the units. Again, why we like the Leibniz notation. First off, what is distance measured in this problem? Meters. You see meters all over this problem here. Meters. So what would area be measured in? Meters what? Squared. Remember, area is squared, volume is cubed. So this dA over dt would be meters squared per, what would be your time? What would time measured in? Seconds. Now for my engineers. How fast, how is this area changing in terms of this massive oil spill that we have on this ruptured tanker? It's 57 pi. Right when the radius reached 19 meters away from the tanker there, how fast is it going? It is gushing out at 179.0707813 meters squared per second. It's gushing out quite large, and it's covering a large area. Every second, you're going to have another 179 meters squared of area being covered with oil. Does that make sense? Understand the numbers behind them. But did I lose you guys anywhere on how to do this particular problem? Because there's lots of things. This is where my science majors honestly get excited about it, because you get to show me what you know. You got to read the problem, draw a picture, label it, come up with the formula that connects whatever picture you happen to see, and go for it from there, and then take the derivative of that equation, plug in what you know, solve for what you're supposed to. So here's another one. A fireman on top of a 75-foot ladder is leaning against a burning building. If someone has tied Sparky the fire dog to the bottom of the ladder, and Sparky takes out after a cat at a rate of 6 feet per second, then what is the rate of change of the fireman on top of the ladder when the ladder is 5 feet off the ground? Number one, read problem. Number two, read problem again, but draw a picture and label it. A fireman on top of a 75-foot ladder is leaning against a burning building. So here we go. Building. Burning. Okay. Ladder. Anytime you got a number, you label it. 75 foot. 75. 75. Good job. 75-foot ladder. Okay? Brave fireman on top of the ladder. Okay? Tell the fireman about that real cool hat he's got on. There it is. Fireman. Okay? Someone has tied Sparky the fire dog to the bottom of the ladder. All right, so here's Sparky. What kind of dog is Sparky? See if you guys went to public North Carolina high schools like I did. You know it's going to be a Dalmatian. Thank you for knowing it's fire marshal day at school there. There it is. All right, there's Sparky the fire dog, and here's his little leash right here, and there is, there we go. Okay. Yep, too much Tom and Jerry. Here it is. Cat. There it is. All right, so Sparky takes off after the cat at a rate of 6 feet per second. That dog's running after that cat. Okay? And as he runs after that cat, now we got the Three Stooges scenario here. What's going to happen to the bottom of the ladder? Since he's tied to the bottom of the ladder, and since the dog takes off, the bottom of the ladder is going to be moving. And if the bottom of the ladder moving, and this is a fixed 75-foot ladder, the bottom of the ladder kicks out, guess what's going to happen to our brave fireman? He's going to be sliding down the wall, right? So I need some variables in this stuff. Now the 75-foot ladder is fixed, but right here is the distance the ladder is against the wall. I'm going to call that X. The brave fireman up here against the wall, against the burning building, I'm going to call this Y. Does that make sense? Direction is everything. Since Sparky the fire dog pulls the ladder with him after he goes after the cat at 6 feet per second, the bottom of the ladder is going to be moving out at 6 feet per second. This is a derivative, feet, hint, 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 per second. Whose derivative is this guy? This is dx over dt. It's the movement in the x direction. dx dt is 6 feet per second. Does that make sense? What are we interested in? Then, what is the rate of change of the fireman on top of the ladder when the ladder is 5 feet off the ground? Here is the top of the ladder, measured by y, that would be the distance. And it's going to be changing because as you kick the bottom of the ladder out, the top of the ladder is going to change, right? And what variable are we going to call that? Well, excuse me, what derivative are we going to call that, being it's a rate of change that we're looking for? Very good. We're going to be looking for dy over dt. When what? The ladder is 5 feet off the ground. So the ladder being 5 feet off the ground, that's when y represents the ladder off the ground, equals 5 feet. I had to come up with the picture for the words. That's your job. Now, what do you see? Because you got to come up with an equation now. What do you see? I see a right triangle. But be careful on right triangles. There's different kinds of right triangles in what you need here. I see a right triangle where I know, or at least have labeled, every aspect of that right triangle. The base, the height, including the hypotenuse, which is 75. That was fixed. So I know something about all the sides of a right triangle. So what theorem, what formula am I going to put in here to come up with an equation to link all these variables together? Pythagorean theorem. So here's where the equation comes from. X squared plus y squared equals 75 squared. That's my equation for the scenario because it's a right triangle in which I know all the parts of the right triangle. The legs as well as the hypotenuse. Does that make sense? Now, what am I going to do to this equation? We're interested in dy dt, which means I got to take this equation and do what with him? Take the derivative with respect to time. So here we go. What is the derivative of x squared with respect to time? 2x dx over dt. Plus, what's the derivative of y squared with respect to time? 2y dy over dt equals, what's the derivative of 75 squared? It's a trick question. It's 0. Don't tell me it's 150. It's not 2 times 75. Don't work like that. It's a constant. Derivative of constant is 0. Now, remember, this is the guy we're trying to solve for, so keep him as the variable. Everybody else you plug into. So this will be 2 times x times dx over dt plus 2 times y times dy over dt, which is what I want to solve for, equals 0. What do we know? Well, I know that dx over dt is 6. So I get to plug in 6 here. I know that y equals 5. We're supposed to find dy dt when y equals 5. So I can replace y with 5. And, of course, there's always one dude they didn't quite give me. Pretty standard. So what am I going to have to go figure out what the x is so I can solve this thing? Go back to the original equation. X squared plus y squared equals 75 squared. X is what we're trying to find here, plus y was given to be 5 squared, equals 75 squared. So x squared plus 25 is equal to, and I'm going to put it on my calculator just to show you, 75 squared is 5,625. I'm going to subtract 25 from both sides. That gives me x squared equals 5,600. And what gets rid of the square so I can solve for it? Square root. Now officially it's plus or minus. You are correct. However, x represents a distance, and distance are always measured to be what? Positive. I want the positive square root. 5,600. It's not a nice number. I just want to show you. The square root of 5,600 is some crappy decimal here, 74.833, whatever. I'm just going to call him that and just put it on my calculator. So I'm going to plug in for x, square root of 5,600. So cleaning this up, this gives me 12 times the square root of 5,600 plus 5 times 2 is 10, dy over dt equals 0. Now go solve for dy over dt. I would subtract 12 square roots of 5,600 from both sides. That gives me 10 dy over dt equals negative 12 times the square root of 5,600. And then I'm going to divide both sides by 10. And then I'm getting dy over dt is equal to negative 12 times the square root of 5,600 divided by 10. Or for you math majors out there that just got to reduce your fractions, fine. Negative 5 square root of 5,600 divided by, negative 6. Square root of negative 6 times the square root of 5,600 divided by 5. But who am I kidding? I've got engineers in here. We just got to know. All right, so negative 6 times the square root 5,600 over arrow divided by 5 gives me negative 89.799777728, but it's a word problem. So it's a law. You got to tell me the units. What would the units be? dy, what would y be measured in over dt? What would time be measured in? Well, the distance is measured in what? Feet. And time is measured in seconds. So this would be feet per second. Does that make sense? One other thing. Pay attention to the problem. I got a negative answer. Does that actually make sense? Why does that make sense in my scenario? Because the ladder is falling down, and remember, these velocities are vectors. They have magnitude and direction. The brave fireman is going 89.7997 feet per second, but negative tells me he's going down towards the source of where I started measuring at. Remember, down or to the left is negative, right and up is considered positive in your orientation. Does that make sense? And also understand the numbers. So I'm going to show you guys something rather cool aspect of your calculator here. I'm going to go over here and go to the apps and scroll down here to the scientific tools. There it is right there, scientific tools. I'm going to use a unit converter because I want you guys to understand this thing. Feet per second, that measures what? Velocity. How much feet per second? We had negative 89.799777728. What were my units? Feet per second. Now this is a scientific calculator, so it moved the decimal place over, negative 8.9 E1 times 10 to the first, which means I need to move the decimal place one place to the right to see that. But what do we want to convert this thing to? So you guys understand how fast our brave fireman is going down the wall. I'm going to convert it to miles per hour. How fast is our brave fireman coming down that wall? 6.1 to E1, which means times 10 to the first. That's 61.2 miles per hour. It's going to hurt. Okay? He's doing 60 miles. Now, really, if you wanted to go into the physics and the physics department to go into this, he's probably not quite going that fast because of the drag and the resistance from the ladder to the wall is going to have some friction to it, but it's still going to hurt. Okay? So whoever tied Sparky the fire dog to the bottom of the ladder should be beaten. All right, so there you go. Does that make sense, though? Understand the physics behind this. This is what kind of section and where you're going with this stuff. All right, still know. Now this one's a web work problem. I think they're all web work problems actually, because I actually made up some problems and then we coded it for web work, and then web work made up some problems and we coded it for your notes. So this one's another web work problem right here, and it's a famous web work problem that everybody every semester has to deal with. It's called the 6-foot-tall woman problem. All right, so here's the deal. A street light is mounted atop of an 11-foot tall pole. A woman, 6 feet tall, walks away from the pole with a speed of 8 feet per second along a straight path. How fast is the tip of her shadow moving when she's 50 feet from the base of the pole? Step 1, read problem. Step 2, read problem again, draw pictures and label it. All right, I got a street light mounted on top of an 11-foot tall pole. So here we go. Here is my pole. Here is the street lamp right here, and there's this glowing right here. All right, and this is 11 foot tall. We have here there were some fingers there. All right, a 6 foot tall woman. Okay, and she's walking away from the pole at a speed of 8 feet per second. Does that make sense? Okay. The question, however, is how fast is the tip of her shadow moving when she is 50 feet from the pole? So you understand, I'm drawing this in midstream. She started over here. And then she started to walk away from the light pole, and this is in midstream. So the light beams will come down here and go all the way over here, and right here you will see the tip of her shadow type thing here. Here's her shadow, and here it is right here. And this is her shadow down here. You with me? And we're interested in this tip of a shadow. Now, a couple things. Let's understand this problem here. We've got to figure out the variables on this thing. Well, there are two real variables here. The first variable is right here. I'm going to call this guy X. And what is this? This is the distance she is away from pole, right? So in midstream. So X equals how far away she is from the pole. But there's got to be another variable, and that variable is what I'm interested in, which is the tip of her shadow. But where does a shadow come from? What creates shadow? Light does. And where's the light calculated at? It is here. So it's got to start here, because when she's here, she's underneath the pole, she actually has very little shadow, right? When it's right, the sun's right above you, noontime, we don't have shadows on the ground. But once the shadow gets behind you or in front of you, then you start casting shadows. So once she starts moving away from the light source, she starts casting a shadow. But the shadow would have started right here. So I'm going to call this variable Y. And this is to the distance to the tip of shadow. Does that make sense? Okay. Got to label everything. What about this 8 feet per second? A couple of things. Pay attention to units and understand them. We've got a woman out here, 6 foot tall, well, who cares, walking away from a light pole. And she's moving away from the light pole at 8 feet per second. 8 feet per second? She's running. You probably should call the police or something or other, guys. Think about it. Know your numbers on these kind of problems. This is web work. They just chunk numbers in this thing. What's going to change? Everybody's woman is going to be 6 feet tall. The light pole is going to change for people. How fast she runs away from or walks away from the light pole also does change depending on the problem. These are the variables on the web work as it regenerates. Everybody has different questions and stuff. So, but all right. But what is this 8 feet per second? What variable is that? It's a derivative because it's a per, but he's derivative of who? Very good. dx dt. So dx over dt is 8 feet per second. What are we interested in this problem? How fast is the tip of her shadow? The tip of the shadow is measured by y. So what we're interested in is what is dy over dt equal to when she is 50 feet from the base of the pole. When she's 50 feet, that's when x equals 50 feet. Does that make sense? I'm looking for dy dt in this problem. Now, you got to come up with an equation for this. This is the trick right here. Because most folks won't see this until you're trained to see it. Where's the equation now? What do you see in this problem? I see a right triangle. But here's the problem. It's not a Pythagorean theorem problem because I know the height, I know the long base over here, I know parts of the base over here, but the one thing I don't know anything about is the hypotenuse. All the hypotenuse is the light beam coming down, hanging on top of her head and creating a shadow on the ground. I know nothing about the hypotenuse. So this is a Pythagorean theorem problem. But here's the deal. You said you see a right triangle. How many right triangles do you see? That's the trick. There are 2 right triangles here. There is a big right triangle. And let's put our variables on this thing. So here is the big right triangle. This is 11 feet. And this bottom thing down here was y. There is a little right triangle, which is right here. You with me? And it deals with her height 6 feet. But I need to know what this variable is right here. The variable right here is actually the distance of her shadow. What is that? What would that be? Tell me. Well, the whole thing is how far? Y. This part was x. We want to know that part. Very good. It's y minus x. Y minus x. This part right here is y minus x. Does that make sense? That's the shadow part. The x was how far she was away from the pole. Y was the total distance, which is what we're interested in. But the actual distance of her shadow at that moment is actually y minus x. Now, because you do not have the hypotenuse, but you've got 2 triangles, this is called similar triangles. And we know from geometry class, 10th grade high school, similar triangles, that the ratio of sides of similar triangles are equal. So, 11 is to y as 6 is to y minus x. Does that make sense? The ratio of sides of similar triangles are equal. The opposite is to the adjacent as the opposite is to the adjacent. They're similar triangles because with these 2 triangles, the angles are all the same. This is the right angle in the corner. This angle up on the top. This angle on the top is the same. This shadow angle here and this angle here is the same. So there you go. Similar triangles. Does that make sense? But now, you got your equation. But because it's a fraction, because the ratio of sides of similar triangles are equal, you got fractions. The first thing I would do before I take its derivative, because you know that's your life in calculus class, take a derivative, you need to get rid of your fractions. So I'm going to multiply both sides by the common denominator. y times x, y minus x. Okay? Now officially what this is going to do is do the famous cross multiplication thing. I want to get rid of fractions. So this is going to give me 11 times y minus x is equal to 6 times y. Does that make sense? And I'm going to go ahead and distribute because I don't like parentheses. 11y minus 6x equals 6y. There's my equation cleaned up a little bit. You can combine it more if you want to, but at any point, yeah, question. Oh, 11. Yes, it would be. Yes, that's my typo. I am 5 steps ahead of you thinking about the next problem. Sorry. There we go. 11. Yeah, distributing 11 would be 11y minus 11x equals 6y. Now, my question to you is this. I could continue to move some variables over, but at any time, you can just stop and take the derivative with respect to time. dt. What is the derivative of 11y with respect to time? 11 dy over dt. Minus, what is the derivative of 11x with respect to time? 11 dx over dt equals, what is the derivative of 6y with respect to time? 6 dy over dt. Right? Now, I'm going to group together what I'm trying to solve for. Remember, in this problem, I'm trying to solve for the dy dt. So I'm going to subtract 11 dy dt from both sides. This cancels. Leaves me with 11, negative 11 dx over dt is equal to, what is 6 dy dt minus 11 dy dt? Negative 5 dy over dt. Does that make sense? Question. Now, what do we know? We know what dx over dt is, right? How fast is that? 8. So this would be a negative 11 times 8 is equal to negative 5 dy over dt. Well, this gives you negative 88 is equal to negative 5 dy over dt. I would divide by negative 5 on both sides, and I get dy over dt equals a positive 88 over 5. Which just so happens to be, and I'll put that on my calculator here, 88 divided by 5 is 17.6 watt. What would my units be? Feet per second. Now, I know what you guys are thinking. Wait a minute. When did I ever plug in x as 50? You never did. You didn't need to. Because she's walking away at a constant rate, her tip of her shadow is moving at a constant rate. So regardless if she's 50 feet away from the pole or 2 feet away from the pole, her tip of her shadow is moving at a constant 17.6 feet per second. Does that make sense? So I didn't need to plug into 50 because after I took my derivatives, all the x's went away and turned into dx dt's, which happened to be equal to 8. Did I lose you guys anywhere on this one? Question. This is a web work problem with your name on it, just like this one, so I'll let you know. All right. But remember the similar triangle trick. That's important. All right, try this one. A snowball melt says that surface area decreases at a rate of 0.01 centimeters squared per minute. Find the rate at which the diameter decreases when the diameter is 8 centimeters. Well, it hadn't been that long ago since we had a snow day in here. So, what does a snowball look like? Sphere. Hopefully that's the kind you make, otherwise it would hurt people. All right, so there it is. Sphere. And the surface area decreases at a rate. A couple of things going on here. Surface area decreases, that's a rate, so rate means derivative. So this would be d surface area over dt equals 0.01 centimeters squared per minute. But what does that word decreases mean to you? Mathematically, negative. Right? It's negative. It's going down. Negative. Now, what are we looking for? Find the rate at which the diameter decreases. So the diameter is the distance from one side of the sphere to the other. I'll call it big D here for diameter. We're looking for the rate at which the diameter decreases. So we're looking for dd over dt equals what when the diameter is 8 centimeters. Does that make sense? All right. We need a formula. They gave me the derivative of surface area, which means I need the surface area formula. Do you guys have to remember from a few seconds ago what the surface area formula for a sphere is? 4 pi r squared. That is awesome. 4 pi r squared. But there's a problem. What does r stand for? What are we interested in? Not the same guy. So we have to convert the formula to the variables we want. What does the radius equal to in terms of diameters? As the radius is equal to what? Diameter divided by 2, half the diameter, right? I can plug this in here, which would give me surface area equals 4 pi parentheses times diameter divided by 2 squared, which means that surface area is equal to 4 pi d squared over 2 squared, which is 4. The 4's cancel, that's nice. And you get a nice equation. Surface area equals pi times diameter squared. That's actually the surface area formula. You take the diameter and square it, multiply it times pi, and that actually gives you the surface area of a sphere. But that's not the dude we want. Here we go. Surface area equals pi d squared. What are we going to do to this guy? We're going to take the derivative with respect to time because we want the rate of change of that diameter. So what's the derivative of surface area? Well, it's a variable. It'll be 1 d surface area over dt equals, pi is a constant, leave it alone. What's the derivative of d squared with respect to time? 2d what? d dt, the guy we want to find. So this gives me d surface area over dt equals 2 pi d dt. Plug in what we know. What was that surface area that we know? They gave that to me. What was it? Negative 0.01 centimeters squared per minute equals 2 pi. We want to find d dt when d equals 8. So plug in 8. d dt. So this gives me negative 0.01 is equal to 16 pi d dt. And what am I going to do to solve this thing? I'm going to divide by 16 pi on both sides and get my answer. dd over dt is equal to negative 0.01 divided by 16 pi, or for you engineers that just want to know, if you're going to put this on the calculator, don't forget to put parentheses around your denominator. Negative 0.01 divided by 16 pi. And I get e negative 4, which means it'll be negative 0.4. Move the decimal place 4 places to the left. 1989, 43679. What would my units be? What would diameter be measured in this problem? Centimeters. And what is time measured in this problem? Minutes. This is the way I want you to do the problem on any kind of test we give you. However, this is a web work problem. And being it's a web work problem, read it. It's an English game. I'm not going to play English games with you. I want you guys to know math. But let's read the question again. And let's answer the question in terms of web work. If a snowball melts so that surface area decreases at a rate of 0.01 centimeters squared per second, find the rate at which the diameter decreases when the diameter is 8 centimeters. Because they said the word decreases in the problem, they're implying the answer is going to already be negative, so you don't have to write the negative. What answer does web work want? It wants the 0.01 over 16 pi, or the 0.00018, 43679. He wants the positive one. Remember that on web work. Because they said the word decrease is there, you don't have to put the negative on web work. On a test, I want to see the negative because I want you guys to understand what's going on. Does that make sense? Question? Yeah. Oh, okay. The surface area of the surface is, because that's an area, would be measured square. We're finding dt, the rate of change of the diameter. How would you measure a diameter? A diameter is a straight distance, so that would just be in centimeters here. Does that make sense there? It's a distance. All right. And so, again, you'll notice that I'm using a lot of the ideas of the Leibniz notation, so it's easier to figure out what my units are going to be and stuff like that. Okay, does that make sense? Well, let's look at this next one. We'll get you started on this one. At noon, Ship A is 30 miles due west of Ship B. Ship A is sailing west at 25 miles per hour, and Ship B is sailing north at 18 miles per hour. How fast in miles per hour is the distance between the ships changing at 5 p.m.? All right, so I'm here and here, and the distance is 30 miles. Just in case you wanted to know, because you guys weren't Boy Scouts or whatever, Girl Scouts. North, south, east, west. There's my compass. All right. Ship A, here is Ship A because it is due west of Ship B right here. Ship A is sailing west at 25 miles per hour. So Ship A is moving this way, and it's sailing at 25 miles per hour. What's that? Yeah, but nautical miles per hour would frustrate people. So we'll just call it miles per hour. All right. Ship B is sailing north at 18 miles per hour. Okay. Now, how fast is the distance between the two ships? So from this point here to this point here, we will call this D for distance. So the question is, what is dd over dt? D standing now for distance. Changing the distance between you changing at 5 p.m. There's my question right there. Step 1, read problem, draw a picture, and label it. Well, I'm going to say Ship A, I'm going to call it X for the distance that Ship A actually moved. So we know Ship A is moving at 25 miles per hour. So the distance that it covered, I'm going to call it X, which means that 25 miles per hour is actually dx over dt. I'm going to say Y is the distance that Ship B actually covers, which means since it's moving at 18 miles per hour, this means that the 18 miles per hour is actually dy over dt. Okay? What kind of picture do you see? I see a right triangle where I'm interested in all the parts, including the hypotenuse. The hypotenuse is the big distance that I'm actually interested in. So what kind of problem is this guy? Pythagorean theorem problem. But be careful, what is the distance for the base of my triangle right here? Very good. X plus 30. Because we remember, I lost my zero there. They first started out 30 miles apart and then they started to move. Does that make sense? So it's X plus 30. So to come up with my equation, I'm going to have X plus 30 squared plus Y squared equals D squared. There's my equation. Does that make sense? Now, what am I going to do to my equation? Did I lose you guys anywhere on that? And the understanding the X plus 30 part for the entire base. Now, what am I going to do? I'm going to take the derivative of this guy. X plus 30 squared plus y squared equals d squared, and take the derivative with respect to time. So this is going to give me, how do I take the derivative of x plus 30 squared? And what rule would I use? The chain rule. Derivative of the outside, 2 pops out front. The inside, x plus 30 stays the same, raised to the first. Times derivative of the inside. Derivative of x is dx over dt. The derivative of 30 would be 0. Does that make sense? Plus, what is the derivative of y squared with respect to time? 2y dy over dt equals, what is the derivative of d squared? 2d dd over dt. Does that make sense? And what are we trying to solve for on this problem? dd over dt. So the rest of these things, and this is the way I want you to look at it, rest of them has to be known quantities that you just literally plug into this thing. There's your dy over dt, here's your y, here's your 2, plus here is your dx over dt, here is your x plus 30, and here's the 2. But when you start plugging stuff in, you're going to see you got a problem. I know what dx over dt is. That was 25. I know what dy over dt is. The dy over dt, that was 18. What is x? What is y? And what is d? I don't know. I got to go find them. And to be able to find these things, you got to use third grade math. Think about it. All right, this thing started at noon. At noon, and we're talking about 5 p.m. In time, how many hours is that? If you start at noon and go to 5 p.m.? 5 hours. Does that make sense? So to figure out what x is, to figure out x as a distance, you're going at, how fast is it going? 25 miles per hour times, how long did you go? 5 hours. Do you know what formula I'm using? Distance equals rate times time. One of those third grade math problems that we came up with years ago. You got to use distance equals rate times time to be able to figure out the distance. So if you're going 25 miles per hour for 5 hours, how far did ship A go? 125 miles. So I get to replace x with 125. Y, and how fast was y going? It was going 18 miles per hour times 5 hours. Y equals, what is that? 90 miles. Does that make sense? 18 times 5. 90 miles. So that is 90 I get to plug in there. And I need to know what d is, and then I can solve this thing. To figure out d, you got to go back to this equation. X plus 30 squared plus y squared equals d squared. Now that I know x is 125 plus 30 squared plus y, which is 90 squared, equals d squared. 125 plus 30, what is that, 155? Squared plus 90 squared is 32,125. 32,125 equals d squared. So what's d going to be equal to? Square root. D equals the square root of 32,125. Not a nice number, so I get to plug it in right here. Square root of 32,125. So now to solve, I'm going to put this on my calculator. That'll be 2 times 125 plus 30, close parentheses, times 25, plus 2 times 90 times 18, and I get 1,990 is equal to 2 times the square root of 32,125 dd over dt. So to solve for dd over dt, I'm going to divide. So dd over dt equals 10,990 divided by 2 times the square root of 32,125. And I'm going to get you that number. 10,990 divided by parentheses 2 times the square root of 32,125. And the answer is 30.6581628 watt. How fast is the ship's changing. Distance between the two ships ain't changing. What would it be measured in? Distance is measured in miles. Time is measured in hours. So this would be miles per hour. Does that make sense? We've got a few more problems that we have to do, but I'll finish those up next time and start section 2.8 next time. So study hard, and don't forget about the Friday review session to help you guys help with this web work problems. See you guys then.